Good afternoon, everyone, and welcome to Sustainable Horizons webinar series. My name is Pooja Rao, and I'm a postdoc at Stony Brook University, and I'll be facilitating today's webinar. So the webinar today is about 55 minutes long, and if you have any questions, you can put them in the chat window, and I'll redirect them to our speaker at various points. If for some reason your questions are not answered during the webinar time, we'll also have an Q&A session after the webinar. During that time, you can either use Zoom chat, or you can also use raise hand option to ask your questions. At all other times, please make sure to keep your mics muted to avoid any sort of feedback. Also, regarding feedback, I would request you all to fill out our feedback form at the end of the webinar. It's very crucial for us to hear from you so we can do better next time and think of better topics to present to you. Most of the questions on the feedback form are multiple choice, except one, I think. So it shouldn't take you more than a minute to fill it out. So please do fill it out before you exit the webinar. Now, without any further delay, let me introduce today's speaker to you, Dr. David Sondak, who we are very happy to have with us. He'll be presenting the webinar today on basics and essentials of version control system. David is a lecturer at the Institute for Applied Computational Sciences at Harvard University. He's been working there since fall of 2017. Before joining Harvard, David worked at UW-Madison as a Ben Black visiting professor and at UTS Austin as a postdoctoral fellow. His research is focused on developing high-fidelity data-driven models in magnetohydrodynamics, thermal convection, and chemical kinetics. David is also very passionate about STEM education and has been involved in a lot of mentoring and outreach activities over the years. He's an avid animal lover and, of course, a very engaging speaker, and I'm really looking forward to the webinar today. Over to you, David.
Say anything more, so I'll just begin. Today, the topic is the basics and essentials of version control, and I'm coming from the point of view of being a computational scientist, where we don't usually get exposed to any dedicated version control courses, although those are sort of coming online a little bit now in the curriculum. But it's an absolutely essential tool for any researcher or software developer or anyone who writes code should do this. And so today I'm just going to motivate it a little bit, and then I'm going to do a little bit of hands-on activities to get you up to speed and then let you spread your wings and have a great time versioning all of your great software needs. So I got two screens here. I think I'm sharing the main screen, and my video is on my other screen. So I'll be looking back and forth between the two. So don't let that distract you. If I don't look like I'm looking at the camera, it's because I'm focusing on coding. All right, here's the plan for today. So really quick introduction to what is version control, why we care about it, why it matters, and then we're just going to dive into Git, which is sort of the version control system of choice these days. I'm going to just kind of cover the bare essentials, how Git works a little bit, and then we'll do a little exercise on how to work with other people, because that's what this is all about. And then we'll, at the very end, conclude with some of the beyond the bare essentials, and that's sort of the plan. All right, so motivation. Version control is a non-negotiable component of any project. And I think I already said these projects can be anything from your software development projects to your research code bases. I knew a guy once who said that he tried to get his family to version control their chores. Didn't work out great for him. I think he got a divorce, but nevertheless, it's a really important thing in life, maybe with some limitations, right? So why do you want to do this? I'm sure you've all seen code directories that look something like this, right? That I'm showing on the screen here. So you have a directory where your code lives. It has some subdirectories. Maybe this looks like this person is trying to send some code to someone, but it's not clear which one is actually being sent, and to whom. And then, of course, you got your original codes, because that was the original state that they don't want to lose. But then there's a whole bunch of final versions and a couple running versions. And at this point, it's not even clear what's happening. And to be very honest with you, back in the day, as a budding computational scientist, I have had code bases that have looked like that in the past. Maybe not quite this bad, but pretty close to this bad. And I know many other people have had this as well. So why do you want to do version control? Reproducibility of your code, maintainability. You need to be able to maintain it in the long term, and then project longevity as well. So this leads to hopefully a robust code that other people can use. And because this is kind of a varied audience, I also want to mention that for faculty and other people who work with groups, you can actually version your entire group's codes if you want through an organization on GitHub, and then have a whole bunch of repos where your students have a central place to actually work on like a real large scale project. So, okay, so for all these reasons, we need to put things under version control. Bunch of examples of version control. There's Mercurial and Git, which many of you have probably seen before. Git is the one we're mostly going to talk about today, but there's also Mercurial, which is sort of a lesser known brother, so to speak. Git has kind of killed Mercurial, unfortunately. These are both examples of distributed version control systems, and I'll talk about what that means in a minute. Then there's your centralized version control systems, which is sort of where things began when people realized we need version control. Concurrent version system, CVS, more or less dead now. Apache Subversion sort of rewrote CVS, and that's actually a very common and popular version control system. I use that on some of my projects as well. And then, of course, you have your popular ones like Google Drive and Dropbox. I'm cautioning, don't use these for software. But even these are starting to have some version control behind the scenes, and they're actually pretty good for collaborating on things. So clearly, I'm not going to talk about those, but that is an example of a repository where that has some versioning behind it. Okay, what do I mean by centralized version control? This is a very easy idea here. The idea is that your code base or your project lives in a central repository somewhere, like in the cloud usually, or some local server, whatever the case is, but the code lives somewhere. And the people who are working on the project will check out the code, a working copy, to their local directory. And then they work and they make changes and they add bugs possibly, or maybe not, and then they have to commit it back to the central repository, and everyone can work simultaneously. And there's some special logic behind the scenes to prevent people from breaking each other's code, right? And if you have any experience with SVN, then you know that there are these things called locks and just different ways that to prevent people from breaking or conflicting with code. Right, and that's the basic idea. It's very simple. The code lives somewhere, and then you copy it down to your local directory, you work and you commit it back up, and you know that the software is taking care of the versioning process for you. Distributed version control, a little bit different, a little bit more general. So in this situation, every person who's working on the project has a full copy of the repository. What I mean by a copy of the repository is I don't mean just a local working copy of the current state. I mean a copy of the entire history that ever existed of the entire project. And so that's really quite beneficial, because now you don't really need, theoretically, you don't really need to have a central repository somewhere. In principle, two people, if they had the address of each other's repositories, could just work with each other remotely, and a third person could join in later and try and sync their repo, but everything's distributed across all these local workstations. In practice, though, what people do is they connect everything with a central repository. And this is essentially what GitHub is, right? Git will still work without GitHub, but practically speaking, people like to have these things in some central repository. And so still, you kind of get the best of both worlds here. Still, whenever you do a checkout or a clone of the central repository, you get the entire history of the code project. And then you also have the benefit of having your project in a central location, in that central repository on GitHub or Bitbucket or GitLab or whatever your favorite thing is. Okay, so that's the whirlwind tour of version control systems. So hopefully I've convinced you that you need to version control everything within reason. and that there's different kinds of version control systems, and that you know a little bit of the difference between centralized and distributed version control. So without further ado, I want to give everyone a chance to really dive into this and see how things work. And the best way to do this is with Git, because that's the most common one right now. Most companies are using it. Of course, internally, companies use different version control systems, but that's a matter of learning different syntax. So what I'm going to do now is I'm going to tell you a little bit about Git. How do you work with it? How's the repo structured? You're going to get a chance to create your own repo and then make some changes and explore the workflow and then work with some other people in the class. And that'll be what's on the horizon for the webinar. Okay, so at this point, you should already have a GitHub account. And I'm operating here under the assumption that you already have a GitHub account. What I want you to do is in your local directory, in your terminal or however you work, create a directory called /webinar. And that's what I've done. So I'm just going to show you on my screen. See, it's a long path, but I have the SHI webinar directory, and inside that directory, I have a whole bunch of things that I use to make the talk. And for today, you're gonna do all your work within the SHI webinar directory. And then what I want you to do is go to the GitHub website, and in the upper right corner, there's a plus symbol, and you can choose new repository. All right, so let me go do that. So you can see my GitHub web dashboard here. And then I go in the upper right corner, and there's a, where did it go? Come on. Plus sign, which got closed a minute ago. And I'm going to create new repository. And in the new repository screen, I'm going to create the repository name. And what I want you to do there is it should be just your first name, _ last name _ playground. And the reason we're doing that way is so that it's easy to identify who it is. Okay, so it looks like there's a question. It says, with regard to access control with Git, can I limit my code sharing recipients to my immediate colleagues? And the answer is yes, and I'll show you that in just half a second, or I'll mention it. So the very next step in creating the new repository gives you the option to do public or private. Public means, and that's what I'm going to ask you to do in this webinar, but of course you don't need to do this in general. The public, everyone can see it. So if they look you up, they can see all of your repos. There's also a way to make private repositories, and then you can choose who can see the commit and commit to the repo. And we're not going to explore private repos today, but it's true, I have a lot of private repos myself. GitHub was just taken over by Microsoft, and Microsoft, being very nice, has now allowed for unlimited private repositories for up to 5 collaborators. Otherwise, you need to get a pro account on GitHub. But you can just go to GitHub and see what their business model is basically for what's available. But essentially, yes, you can choose who can access the repo or not by choosing public or private. So choose a public repository today. I'm going to ask you to initialize it with a README, and then you're going to create a gitignore file, which I'll explain in just a second. And I'm choosing Python just for fun, all right? So initializing the repository with a README. The README is basically the hello world to your repository. People like to put some little mini documentation in the README, basically how to set up your code base. And the gitignore file is extremely important. You pretty much always want to have a gitignore file. I'll say much more about this later, but for now, the gitignore file just is so that Git knows which junk files to ignore when you're about to commit things to your code base. And I'll talk about that much later. A little bit later, much more. Of course, you also have the option of adding a license, which I'm just not going to do here because there's not even any code. All right, create the repository. If all goes well, now I have a beautiful new repository with a gitignore and a README, and all the README does is say David Sondak Playground. Okay. So before we dive in and start to actually do the exercises, I'm going to give you a little bit of background on what Git does, or the anatomy of Git, I guess is the better way of putting that. So there are four kind of blocks here on my screen, and this is sort of the anatomy of Git. The working directory, that's where you're doing all your coding and all your work. That was essentially going to be this playground repository that you just created in a minute. Then there's a thing called the staging area. The staging area is a nice little thing that Git has. Essentially what it's used for is to stage a whole bunch of changes that you think you might want to commit to the repository. It's a really handy device to have. It allows you to just figure out what you're going to commit in sort of logical chunks, right? When you're in the staging area, you haven't actually committed anything, and Git is not tracking any of the history of the file yet. You're just saying to yourself, I think I'm going to want to push or commit this later on, and so I'm going to set the stage with all these different files. Once you're happy with the staging area, then you're going to commit things to your local repository. The local repository is where the Git history and on all the versions of the code that ever existed live. That's your local repository. It's an exact copy of the code base as it is right now on your local machine. And then the final stage is the upstream repository. That's the centralized structure on GitHub where really the project lives, and that's where you're going to interact with your colleagues usually. So what do you do first? The very first thing you do if you want to get a repository is you clone it. Clone means essentially that you're downloading the repository to your local workspace. So you have the upstream repository, you clone it down into your working directory, and then you make some changes, and that's going to change the status of the working directory. And we're going to go through the status later, but what it means is that you're going to be checking to see what state your current repo is. Is it in sync with the upstream or not, right? And which files have you added, which files are ready to be committed. Once your status is in telling you that things are the way you want it, then you stage the changes into the staging area. That's called adding things to the staging area in Git. And then when you're happy with the staging area, then you commit to the local repository. And at that point, your local repository is up to date with whatever was in the upstream when you cloned and with whatever changes you made locally. And then you push to the upstream repository, which is going to allow you to have everything up to date with the main project base. So that's the anatomy. Then you want to update your local repository. So you fetch the changes from the upstream repository. So if you're following along, let me just recap what's happened so far. You have this upstream repository which contains the code base. You clone everything down to your working directory where you make some changes, right? Then you find a way to push it back up to the upstream repository. Later on, you want to update your working directory and you want to update your local repository with changes that other people have made to the project. And you do this not by cloning, because you've already cloned, you do this by fetching. So you're going to fetch, and that means you're downloading the current state of the project. Then, after you fetch, you merge into your working directory. Now this fetch merge step, some of you may have seen before, is combined into one command called git pull. And I'll tell you later, git pull is not what you should be doing, but it's a combination of the fetch and the merge. So it downloads things and it merges it into your local code base. Okay, that is the whirlwind overview of the Git anatomy, the essential kind of basic workflow of Git. Now we want to put it into practice. So let's start doing things. So the very first step is to clone the repository. So this slide here, slide number 10, shows the state of my repo, and I'm going to tell you to clone it. So the way you're going to do that is you go over here to the clone or download green button, you click on it, you click the little clipboard, which means copy, and then you go back to your SHI webinar. I have a demos directory that I'm going to go into. I'm going to git clone, and then the name, I just paste the thing that I just copied, and git goes through, and now I have my repo, David Sondak Playground. All right, so I'll give you a minute to do that. So everyone should do that little exercise. Go to the repo you just created, not my repo, go to your repo and clone it to your webinar directory. That should work just swell. So there's a question, how would a Windows user do this? So there were, I believe we released instructions ahead of time on getting Git Bash on Windows. So I'd encourage you to set that up. All right. So I'm going to move on because the Git cloning process should have worked pretty smoothly. So now let's explore the repository a little bit. So I want you to go into your new repository. So I'm going to enter my new repository. And from the command line, type git log. And when do we have to create a directory? You should have created the directory in slide number 7. Back when you wanted you to create a new directory called SHI Webinar, and then we created the repository, and then I want you to clone the repository. Yeah, okay. All right, so you've done the git clone, and now you have your cloned repository, and so if you type git log, this is going to be able to tell you all the information about the history of the commit history of this repository. So what you see here is this big ugly thing, commit, and then this garbled mess of numbers. All that garbled mess of numbers is a unique ID to the commit, right? So you don't have to worry if you're just a consumer of Git. Just know that that's there for it's secure, and it has like this unique code, right? And then there's some information that tells you a little bit of some details that we're not going to get into right now. Then it says who the author of that commit was. It was me, and yours should say your name. And you'll notice that I have my email address set to this weird email address because I made my email address private so no one can see it. And then there's the date when that commit occurred, and then the name is just initial commit. And that's all the information that you could ever need, right? And as you go through your Git project, this Git log is going to get longer and longer because it's going to have all the history of all the commits that ever occurred in the project. All right, up to this point. Okay, so now we're going to start poking around some more. We did the git log, a very useful command. And by the way, if you want to see more information on git log, just go to the git log, what's it called? The help page. You see all sorts of options for git log, and I'm not going to go into that. Just git log is your friend, and it shows you all the history. Git status, which we're up to now, is also your friend. Git status is going to tell you the current state of the working directory. So if I type git status, I get a bunch of messages. It says I'm on the master branch, which is sort of the default branch in Git. We are not going to get to talk about branches today, so don't worry too much about that. And then it just says that this branch is up to date with the origin master branch. Origin is the upstream repository. So what this is telling me is that I have not made any changes to my local repository that the origin, the Git repo, doesn't know about. And so then it tells me that there's nothing to commit and the working tree is clean. So everything's all fine. A very boring message. Boring isn't always bad. It just means that everything's working just swell. So this is a window into the current state of your project, and you should use this all the time. And you're going to get to use it quite a bit in a little bit, where you're going to see how the Git status changes depending on what actual action you're taking. All right, so now there's a few special files and directories in here. The gitignore file is one of my all-time favorite files. tells us it tells Git what files to ignore when adding files to the index and committing to the local repository. And currently we've specialized this to Python, but of course it could be applied to a whole bunch of other types of codes, like C++, MATLAB, Julia, whatever your favorite code to use is. You can write a git ignore file. So what is it? Well, first thing you need to know about the git ignore file is that's a hidden file. You see on my slides how git ignore is preceded by a dot? That means it's hidden. So if I just try to list all the files in the directory, I only see readme. But if I do ls-a, all of a sudden I get a list of a bunch of other things. And one of them is the git ignore file. And if I look inside the git ignore file, I see all of these junk files that I never ever want to push to any kind of Git repo. Right? That's what's supposed to be in the git ignore. So you'll see that we have these PyCache files, which contain some Python optimized codes, C extensions, egg files for packaging. I mean, just all this junk that you don't ever want to have in your Git repo polluting it. And so you can just create this git ignore file, and Git will automatically know to ignore it. So you should always have a git ignore file in your project. That's rule number one. Now, inside of this directory, we also have this .git hidden directory. And you shouldn't, if you're just using Git for fun and for projects, you don't really need to go inside this Git hidden directory. But I need to mention it because this is where everything is. So this is where Git your local repository actually lives here. This is where Git keeps track of all the history and the remote repositories and everything that you have going on. So if I look inside the config file inside of the Git hidden directory, I see this remote origin, I see the master branch. And so these are all the things that my Git repository is aware of. And in a little bit more intermediate step, you can create more branches, you can create different remotes, you can do all sorts of stuff. And all of that stuff lives inside the Git hidden directory. Okay, so that's a little bit technical. That's about as technical as we're going to get today. The key point there is that you should have a git ignore file for your code base, for your repos, and that all of the Git information for your local repository lives inside the hidden Git directory. That's what you need to know from that. Okay. Next step. Now we're going to do fun things. So we're going to make some changes. Suppose you want to add a new file to the project. The standard workflow, the very basic standard workflow here, is to edit the file or create it, add it to the staging area, commit it to your local repository, and then push to the remote repository. So what I'm going to do is, and you should do it too, you should do it with me, change the README file. So I open up the README file. Whatever text editor you want to use is fine with me. I don't care if you use VI or if you use Atom or Emacs, whatever you want to use. All right, so the heading here is, I don't think this is a good heading, so I'm going to change it to David's Playground. And then I'm going to say this is a place to play with Git. Oh, and I should put it in quotes so it actually renders nicely. Okay, good. So I changed the README. Oh, I see there's a question. Will we get a copy of this PDF for future reference? Yes. Yes, you will. All right, so back to the Git. So I just edited my README, and it hasn't been staged yet. So let me do a Git status. Here's what we're going to see. It says you're on branch master. Your master branch is up to date with a repo, the remote repository. But it tells me that there are some changes that have not been staged for commit. And that makes sense because we just made the changes, and it tells me what those changes are. It says that you've modified the README file, and you haven't changed anything, or you haven't added the changes to the local repo yet. Oh, someone asked me a question about what did you do to quit from editing the README? I'm using VI, so let me open that up again. So I opened up the README. If you want to quit, type colon, so shift colon, right, colon, and then W writes, and then Q, and then hit enter. So if you see the bottom left of my screen, it says colon WQ, that'll exit from the VI editor. All right. Did everyone follow that? I'll do one more thing here, right? So colon WQ, right? Enter. All right. So that's how you exit from the VI. You don't have to use VI. If you want to use Atom, that's fine too. There's another question. How do I get the $ command line in the editor Atom? I don't understand that question. Maybe Wendy can answer that one. Not sure the answer to that. And then how can we create, another question came up, how can we create a gitignore file in an existing repository? That one, you're gonna, well, we'll do an exercise later where I'll show you that. Basically what you wanna do there is you wanna create a new file. Right now we just edited a file, but you can open a new file and create it, right? And then you'll be all set. So that shouldn't be a problem, right? If I wanna create a gitignore file, I just create a .gitignore and I put all the things I want in, and then I do a git add and a git push, and it'll work out just great. Okay, I hope that answered your question. All right, so now, okay, so back to git status. I do git status, it tells me that I've modified README, and now what I want to do is I want to add this to my staging area. So I just do I should update the slide, right? So we want to do a git add. So I'll do git add readme.md. And now we do another git status. See, Git didn't give me any message after I do git add. So I always do git status because I do that because I like to see the green because it makes me feel like I've made progress. You see how my terminal now says modified readme. Now the red turned to green. So now Git says I'm prepared to track this file now. So Git knows about it because I've staged that file. It knows about the changes. I haven't committed the changes to my local repo yet, but I've at least ready to do that now. And so now we're about ready to do a git commit. Before doing that, I have to say something very, very important. Never use git add dot unless you're Git Pro. Git add dot stages all the files in your repo and even things you might not want to stage. And if you don't have a good gitignore file, sometimes you will end up staging junk files like .ds_store, which is a Mac file that Macs like to write out. And some people I work with do a git add dot, probably because they're a little bit lazy and in a rush, and then the repos get polluted with all these junk files, and it's just unendingly stressful. No matter how much I troll them, they will not stop using git add dot. So don't even get in the habit. Just never use git add dot until you know what you're doing. All right, that's the rule. Okay, and as I said before, the staging area is useful for working toward a full commit. So if I wanted to add another file, I can do that too, right? So I could create a new file, stage it, and then if I do git status, I'll see that I have multiple files, all right? Okay. So let's go to the next step. We're going to update the local repository now with the git commit. So the way to do this, I'm going to type it into my terminal again, is git commit -m. The -m option means message. And I put quotes, and then I'm going to come up with a good commit message. And this is super important. So, you know, I would like to write some kind of cheeky message, but to set a good standard, I'm going to write an actual good message. So git commit -m changed README heading and content. All right. And then I hit enter. And then Git tells me that the master branch has this commit. The commit message is changed README heading and content. And it says 1 file changed, 3 insertions, and 1 deletion. And that makes sense because in my case, I deleted the first line and then I added a new line there. and then I put a space, which is another line, and then I added some text, right? So there were my 3 insertions and my 1 deletion. Okay, so we're in good shape now. So these changes now have a permanent record in my local repository. The remote repository still doesn't know anything about it, but we're going to remedy that in just a second. First, I want to say every commit has 2 features that you should be aware of. First is this hash, which is a info about that commit. Don't worry too much about that. We've already alluded to that a little bit. I just said that's the unique identifier, and it's like makes things secure mostly, and it's okay. All right, so that's one aspect. The other thing that a commit has is a good commit. You could write a whole chapter in a Git book on writing good commit messages, because is another thing I see a lot of times with collaborators. They write the most awful, horrid commit messages. I've seen people write a string of A's as their commit message. Like, what does that mean? How am I supposed to know what changes you made? I have no idea what you're thinking. I've seen people write arg like they're mad, right? Like, okay, you're mad, but what did you do to make yourself mad? So you have to write a good commit message, and it doesn't have to be long. It just has to be concise, to the point, and so we understand exactly what is you did, right? So that's just kind of at good etiquette. Okay, yeah, so this is a good point. Someone just said a good commit message should say why you made the commit, not just what you changed. I totally agree with you there, yeah. So that's a good clarification. You don't want to just say what you changed, but yeah, maybe say why, right? So I could have said in mine, change README heading and content to be more informative, right? So clearly that's still a short commit message, and we just let them know why that had to be changed. Good point. Okay, moving on now. So I just have a few comments on git commit, a few handy options you might like to know about. The one we just used was git commit -m. If I hadn't used the -m, then Git would open up my default text editor, which in my case is VI. But it's nice to be able to just have a commit message right on the command line there. Then there's git commit -a, which is a shorthand to stage and commit a file which is already tracked. This is super useful because in our case, for example, the README was already tracked, so I could have just done git commit -a, and that would have added it and committed it all in one step. Note that, of course, git commit -a is, if the file is not tracked yet, then it is not going to start tracking it, right? So you have to manually start tracking the file with git add. But after that, you can use git commit -a. And just so you know, you can put both of these commands together, git commit -a -m, and then you have some informative message. There's a lot of different options here. So if you go to the Git documentation, here's the Git commit documentation. Here's all the options. I'm scrolling through them. They're just a lot of different things you can do. Okay. So now we want to update the remote repository. And the way to do that is with a git push. So git push attempts to update the remote repo. Here's where we are in this whole process. We made some changes to the working directory. We staged them. We committed them to our local repository. And then you're going to push them to the upstream repository. So let me do that. Git push. And voila, great success. So it tells me how many objects it changed. It has a bunch of Git messages, which we're not going to get into. And then it says where it was pushed to. It has something about the commit hash. It tells what branches. And it didn't give me any errors, so I guess everything is great. And so now we get to go look at what happened. So I'm going to go back to my repo. I'll refresh it. And now my repo looks legit, right? I have David's Playground, and it says a place to play with Git. And we're happy. Okay. So I'll give you a minute. Maybe we can send out a poll, Wendy, to just see if people have caught up. So the next thing we're going to do is we're going to do a an exercise, and I want to make sure people are up to speed before we, or at least most people are up to speed before we move on.
Guys, you should be seeing a poll in front of you pop up, so please fill that poll out. Thank you.
This So someone is asking, they're saying they didn't get any response from Git on any of the commands. Yeah, I don't know. I haven't seen that before, other than what Andy is saying is that you might have gotten a pop-up that asked for your login and password. That's possible. There is a verbose setting for different things, but you should have gotten some response from Git about that.
Has everyone participated in the poll? I'm going to go ahead and close it. You got just a few seconds to get your vote in.
Okay, cool. So we're like, what is that? 87% caught up. So I'm gonna say that's pretty good. The good news is that, why do I have this funny streak on my, I don't know. All right, so what I want you to do for this exercise is Wendy's gonna put in, oh, okay, before I move on, there's a good question up here. So someone asked, any comment on use of the Git GUI versus command line? Actually, I meant to mention this in the very beginning. There are GUIs out there for using Git, and the reason I don't do it in my webinars and seminars and classes is because I don't want to be partial or biased to any one of those GUIs. There are many good ones out there, and depending on what your work culture is like or your group is like, you might use a different GUI. I'm not particularly opposed to them. The benefit of doing things from the command line is that you actually have to think about what you're doing. So that's why I like to use the command line when I teach classes. And then hopefully you have a good plan for going forward. And if you want to use the GUI, go for it. And you can choose whichever one you like. Okay. I don't know why I have this yellow streak on my presentation, Wendy. Did I accidentally, is there a way to delete that?
Yeah, up at the top when you have your presenter controls, I think that you've done some sort of annotation, and there should be a clear
All right, I see it.
option.
All right, great. Thanks, Wendy. Okay, good. So here's how we're going to do this exercise. Wendy's going to put you in breakout rooms of 4 people each. And then what I want you to do is I want you to find one partner in the room. So there'll be 2 groups in each room. I don't care which, who you make your partner with. And I want you to clone the repository. Now, since everyone set up the public repository, all you really need is that other person's GitHub ID, and you can go to their page and find their repo. And it's public, so you can just clone it. And then what I want you to do once you've cloned the repository is I want you to edit the README and update the repository. So use the edit, add, commit, and push workflow, right, that we just did. So you're going to just do it on your own, but you're going to edit their README in their repository. So what that'll look like over here is, you see I have David Sondag playground and Sayaka Masuko playground. So I have my playground, and then that's my wife's playground, right? I was practicing with her. So, so you'll have something that looks like this. You'll have your own playground, and you'll have your partner's playground. You're going to edit their README, and then you're going to, and once you push, you're going to push the changes to their repo, and then you should go and make sure that everything on your repo is updated. And then you're going to go back to your repo and type git pull, and you'll have the local changes. Everything will be up to date. Okay, that's the exercise. there's a question. Why is your Git in the README has a gray background on the GitHub page? Oh, because I put it in quotes. That's why. So if you go to my README, you see how I put Git in quotes here? That's just how I denote like teletype text. So like we know that it's a code type thing. Oh yeah, good. Okay, great. So I guess I'll give you about 10 minutes to try this exercise, and then we'll carry on. So given the time constraints, I hope everyone was able to be successful or at least learn something from that process. Given the time constraints, the original plan was to show you a little bit of merge conflicts because that's one big reason why people give up with Git, but I don't think we're going to have enough time to do that. So I'm going to go to my just summary over here and we'll stay a little bit after and do this merge conflict demo to show you how to resolve merge conflicts in the right way. So, oh, someone said, I think some of us missed how to share our repo on GitHub with our partner so that we could push our changes back up. Ah, all right, that's important. You can, there you have a couple options here. If it's a public repo, it should just work no problem, but you might sometimes need to give them access. So in step 2 here in the slides, which I shared now in chat, by the way, it says you can add your partner as a collaborator in your repo via the settings tab. So they'll have to give you the GitHub ID, but you can go over here to settings, and then under settings, there's an option for collaborators, and then you usually have to put your password in. And then you can add a collaborator down here where it says search by username, full name, or email address. So whatever their GitHub ID is, you can add the collaborator, and that will definitely solve the problem. Okay, so let me just summarize what we've done today, and then later on we can come back and talk about the merge conflicts if people want to hang around a little bit. So Git's very powerful. Don't be intimidated by it. If you break your repo, do not simply delete it and reclone. That's a very common thing people like to do. Don't do that. There are a lot of great resources out there for Git. The Git Simple Guide is one of my all-time favorite ones. Very easy and well written. Atlassian Git tutorial is my other super favorite one. I think it's beautiful. It's by the Atlassian's the people who make Bitbucket. So even though we use GitHub today, Bitbucket is another place where you can go to another type of repo. And there's a whole bunch of other things you should think about. Basic terminology, like what does head mean? You've got your remotes, how to sync to those. We totally glazed over that. Branches, we kind of mentioned them, but we didn't talk about that. It's a very important software workflow. Resolving merge conflicts, and how to reset and revert repositories and possibly rewrite history with Git. So I have links to all these things for you. If you want to check them out, just click on there and it'll be taken to the Atlassian tutorial for that page. So the basic workflow when you're using Git is you host the software project somewhere. So that might be GitHub or Bitbucket or GitLab. And then you check the software to your local workstation using git clone, make your changes, add them to the staging area, commit to your local repo, and then run some tests. We didn't talk about that at all. And then you push it to the remote repository. You should always version control your projects. Never delete a repo to fix it. Be patient in learning good version control practices. It's going to pay off. You'll have a lot of fun with it. Commit early and commit often. So this means use atomic commits and this kind of thing. It'll make you feel like you're super productive because you'll see that you have made a lot of progress over the last year. Because on GitHub they have this. Let me show you my profile. Right, so they have how many contributions in the past year, and it looks really cool when you have a lot, right? So if you do a lot of commits, then it'll look cooler. Hopefully that's motivation. All right. And the last little thing I want to mention in the last minute or two here is just this idea of project management. So I hope that you have a little bit of idea now of the basics of using Git and using version control, but it definitely doesn't end here. So you have to go to the intermediate level where you start learning about branches and this kind of thing. But actually, these things are usually part of a larger project, right? And so for real projects, for example, this image I have on my slides where it has like 3,500 commits, 30 branches, 29 contributors, that's a decently sized project. You really should use some kind of actual project management. And GitHub has that built into it. So you have your code. If you go to your repo, you'll see this tab at the top for code. This particular code base has 66 issues. So you can create an issue by clicking on the issue tracker. Where is it? Oh, I might not have it here because I haven't made any. There it is. Issues. You can create an issue, and that'll be like, your code is terrible, this has this bug in it, and then the developers have the code to fix it. So that's what the issues are for. You can create pull requests, which basically says, look, I have my code base, and I'd like you to pull some of my new features into your code base. That's what a pull request does. You can create projects on the projects tab. This allows you to create tasks and pair them up with issues. You can create Kanban boards and other project management tools. It's really quite nice. So I'd encourage you all, if you have a decent code base, to try and use the full functionality of GitHub, which will include creating projects and everything. All right, so I think it's exactly 4 o'clock now. I'd be happy to take questions. If you want to see the GitHub merge conflict or the Git merge conflict demo, Pooja and I will do that in a minute. And thank you for your attention.
Thank you, David. That was a great talk. And guys, stick around for any more questions that you have. David will be here for another 15 minutes or so to answer your questions. Excuse me. And Wendy will be posting a link to the feedback form in the chat right now, so please fill that out too. Thank you so much, and over to you again, David. Let's see what's there in the chat.
So far, everyone's saying they're inspired to use Git. That's really great. Maybe we want to do the merge conflict, Pooja, and then if people have questions, we can address it. I can address it as they pop up. What do you think?
Yes, sounds great. Let's do it.
All right, so I'm back to the slides here. Before we start, someone's asking what's the difference between GitHub and GitLab. So GitHub and GitLab are both cloud services, and they have just slightly different feature sets. I mean, I've looked into this quite a bit, and I have not converted to one over the other. So you can do this GitHub versus GitLab, and you'll see, I found a really nice chart somewhere. That's not it. This person's switching to GitLab, it looks like, from GitHub. All right, so there's a whole bunch of reasons why it's good. I mean, frankly, I don't really have much of a preference between GitHub and GitLab at this point. I use GitHub because a lot of my projects are already there. Okay, so here's what we're gonna do with the merge conflicts. A common pattern is the following. There's two people, call them Sally and Joe. They're working on the same repository. Sally makes a change to the code, commits those changes locally, pushes to the remote, and goes home and has lunch and plays with her dog, whatever she wants to do. Meanwhile, I mean, at the same time, like, Joe happens to be making changes to the code, and possibly he changes the same piece of code, the same line. He commits his changes locally, and he tries to push to the remote, and Git's going to complain and say, I don't know who's right here, so I'm going to prevent Joe from pushing. So Joe realizes he's made a big mistake because he should have updated his repo before working on things. So now he decides he's going to try and update the repo. So he tries to pull in Sally's changes using a git pull to his local repo, and he gets a merge conflict. And people always panic when they see merge conflicts. And what ends up happening is Git says, all right, Joe, I don't know which things you want me to keep. So I'm going to keep both, and I'm going to tell you what's on your local version, and I'm going to tell you what's on the remote that you tried to pull from, and you get to decide which one to keep. And the way Git does that is by showing this kind of looks like opaque notation, but it's really not so bad. You have this less than signs, and then it says head, and then it has the piece of code that's in conflict, and then it has a bunch of equal signs. And that head basically says, this is the code that's in conflict, and this is the version that I have on your local repository. The head means that's the current state of your local repository. And then underneath those equal signs, there's Sally's contribution to the same line of code. And then underneath that, you have all these greater than signs pointing to the origin/master, which is the name of the remote repository. And so that's saying that this is the version that's living on the remote repository. So Joe has to figure out which one of those to keep. It's possible that he knows which one to keep. Maybe he knows that his is better, and so he just keeps his. It's also possible that he needs to call Sally up and say, Sally, we have a merge conflict. We need to talk about which one's the right one to merge, right? Git can't do that ahead of time for you. So what Pooja and I are going to do is we are going to follow this kind of procedure. So the way it's going to work is, right now, I don't think Pooja's going to share her screen, but what she's going to do is she's going to clone my playground repo. And I guess I should add you as a collaborator, huh, Pooja?
Yes.
What is it? P-R?
P-O-J-A, Pooja Rao 8.
There we go. All right, add collaborator. All right, so she'll accept it. Now she's going to clone my repository, and then she's going to update the README. And I guess what you should do, Pooja, is change it from the name of the README, as David's Playground, change it to Pooja's Playground.
Okay, on top of it.
Okay, and what I'm going to do in the meantime is I'm going to change it to David and Pooja's Playground. Right, so then I made an edit. I do a change, so it says changing the repo name to be more inclusive, right? So maybe we're working on this code together or something. All right. Pooja, did you push? Let me know when.
I'm getting an error, so let me try to see what that error is.
Okay.
Permission to add to your directory, to your repository denied.
Oh.
So let me make sure that I'm added to your.
It says awaiting your response.
Okay. Okay, so I have a notification and I'm going to accept David's invitation.
Yeah.
All right. And okay, let's see if that went through. Accept invitation, and I should be added now.
Okay, good. Yep, now you're added.
Okay, perfect. All right, so I've made the change. I've changed it to Pooja's Pooja's Playground, and I have added my file and I've committed. And now I'm going to push to David's repo. Okay, entered my GitHub ID and password, and done.
All right, good. So now my repo now says Pooja's Playground, and we know that that's not right? But because I've made my changes, so I'm going to do a git push, and it says rejected, right? So my contribution to my own repo has been rejected, and that's because I didn't update the repo before I tried to start working on this, right? So it's out of sync with the remote repository. And so what I'm going to try to do now is I'm going to do a git pull, because I realized that the reason this problem happened is because I wasn't up to date, right? See, it says updates were rejected because the remote contains work that you do not have locally. Okay, so that's the answer. So now I do a git pull. And now I have another problem. It says it's merging README conflict. Merge conflict in README. Automatic merge failed. You need to fix the conflicts and then commit the result. And I've seen a lot of people just give up with Git at this point. But what we're going to do instead is you're going to open up README. And this is exactly the message that you expect. So here's the head. This is what is in my current repository, David and Pooja's Playground. And then this over here is Pooja's Playground, and it points to the latest commit in my repo that was associated to. Now I happen to know that I don't want it to be Pooja's Playground, so I'm going to delete that part, and I'm just going to keep my change. And now I do a git push or a git commit, and I'm going to change it so updating or fixing merge conflict, fix merge conflict, fix readme merge conflict. All right, and then I do a git push, and now everything worked out just swell. So I go back to my readme, I refresh it, and there it says David and Pooja's Playground. Okay, so that was just a simple demo of how to resolve a merge conflict with Git. So if you do get a merge conflict, you shouldn't be afraid that things are breaking down. You should just realize that maybe you didn't follow the right Git practices. And the right Git practice are actually to use not Git pull, but to use the fetch merge paradigm. So what you really want to do is you want to do a fetch, and then you can check the differences between your local repo and the upstream, resolve conflicts, and then you can do a merge to avoid the conflicts. All right, so a proper explanation requires discussion of branches and remotes, and you can find those at these nice little references. Okay, so that's our little merge conflict demo for you, and it doesn't look like there have been any more questions. Are there any other questions? We got 4 more minutes.
If there are not any other questions, David, can you talk a little bit about the branches in Git?
Oh, yeah, well, I didn't prepare the slides for those, but I can talk a little bit about this. I mean, I can just talk out loud about it. So the basic idea of branching is you can think, I think I need to show a picture. So I fortunately have a link to a tutorial. So this is why I love the Atlassian tutorials. They have such nice pictures. So you can think of your Git workflow as sort of this line, and the little blobs on the line represent commits along the way, which is exactly what we've been doing this whole webinar. But sometimes, and actually all the time, you're going to want to branch off to create a new feature, and you don't want that new feature to interfere with the workflow of what's going on upstream, right? Maybe it's some kind of bug fix, or it's just a new feature. Whatever the case is, you decide to branch off of the mainstream. That's the idea. And so by doing that branch, you've now created another little commit line, which is going to create your own little commits in your own branch, which is separate from the master branch, and you get to rename your branch whatever you want. You should name it like bug fix or something like that. And then when you're ready, and only when you're ready, then you can move the changes from that branch back into the main stream. And that's done through a git merge. So that's the basic idea. So you should always use branches in a real software project. And actually, as you do it more, it's not so hard. I mean, there's commands, git branch commands. Okay, there's a question. You said do not simply delete the broken repo and reclone. Then what is the proper way to fix the broken repo? So it depends on what you mean by broken. I called it broken because there's lots of different ways for things to be broken. One way is a merge conflict. That's the one I had in mind when I wrote broken. So people often think that a merge conflict means things are broken and they delete the repo and they reclone it. Now you know how to resolve merge conflicts. There are other ways that things can be broken. One way is that someone along the line made a change, a commit, and that was the wrong commit to make. And so what you actually want to do sometimes is you want to revert your history back to the original, that previous commit. That's one of the controversial topics in Git called rewriting history. And I'm not going to go down that rabbit hole today, but there are things called Git reset and Git revert, which allow you to roll back your repository to a previous state. You sometimes need to do that as well. So those are the basic reasons how you're going to fix a broken repo. The one that comes up the most, at least especially for beginners, is the merge conflicts. All right, so I'll just say a couple more words about the branching. There's kind of two kinds of branches. There's the local branch and there's a remote branches. So you can create local branches just in your own repository that your collaborators will never know about. And that might just be for your own fun, right? Your little features here and there. But there are long-lived branches that you can create on the remote repository. And those branches might be for some long-term feature that you're trying to build in that multiple people are working on, but you don't want it to be part of the main code yet. And so what'll end up happening is you'll have this long-lived branch when it's containing some feature. When it's ready to be merged into the main code, you're gonna do like a you'll do like a pull request from that branch into the master branch. All right, and then, okay, that's pretty much it about the branches. So when you hear about branches, you just think, oh, how to commit different messages for multiple files. Oh, very nice question. So this gets to the point of when you should be committing, right? So I said you should be doing atomic commits. So what you're going to want to do is you have to decide what a commit means. So a commit might mean that you're only committing one file, or a commit might mean that you're committing a few files because they're all part of a bigger fix, right? So if you want to just commit different messages for multiple files, the best way to do that is just to stage each file individually and commit it, and then have that name. If you have multiple files, then the default behavior is that they're all going to get the same commit message. And so that's a really nice question, because it actually gets to the point of, when should you really be committing and what should you be committing? So that's it. So if the files that are grouped together in the staging area are all going to have the same commit message because they're all for the same purpose. That's it.
All right, thank you, David. So if there are no new questions, we'll wrap up the session right now. Thank you so much to everyone, and thank you so much, David. And we learned a lot about Git. We'll be posting the video recording and the slides on the SHI webpage soon. I think Wendy will send out an email with all the details. So please look out for that email. And again, thank you so much.
Okay, thank you all for coming. It was fun.